Good morning to all. Today we are discussing about the data structure and the data structure concept of hashing techniques. Okay. In the fifth unit, we have two important topics. One is shorting techniques and another is hashing techniques. Both topics are very important topics under the fifth unit. Already I explained about the shorting technique with the internal shorting and external shorting. Okay. What do internal shorting means? Internal shorting to short the data within a computer is called as internal shorting. To short the data into external devices is external memory locations is called as external shorting. I briefly explained the concept of internal shorting and external shorting with the different shorting techniques I explained. So I am going to explain the another important techniques, the hashing techniques. What is hashing? Hashing is the process of indexing and retrieving element in a data structure and provide a faster way of finding the element using a hash key or hash value generated using a hash function. If without a hashing technique, so hashing technique is nothing but just create a hash value for the each and every element. Based on the key value, you can store the data in your computer memory locations. It's called as a hashing technique. Without what the purpose of hashing and what the advantage of hashing is, if you are not implemented the hashing techniques in your computer, it's very difficult to retrieve the data. Otherwise, store the data in your computer is very difficult. If you are using a hashing techniques, means it's easy to retrieve the data from your computer. Otherwise, store the data in your computer or finding the data in your computer is the easiest method. Faster way of finding the element using a hash key or hash value generated by hash functions. Just as a key is how to create a key means using a hash function. Then hash function based on the hash value. Based on the hash value, you can store the data in your computer memory location. What the hash value is? The hash value based on the array index. The hash value 0, the array index of 0, then hash value 1, 2, 3. These are the hash value based on the hashing array index. Then it's an example of one hashing with the phone book. Hash table size is m equal to 5. Then m equal to 5 is nothing but the 5 memory locations in your computer start from the 0 to 4. It's called as a hash table. As of 0, 1, 2, 3, 4. Okay, from array location 0 to 5. Then how to generate the hash key value means using a hash function h of k equal to length of key modulus of 5. Okay. Then remainder value, based on the remainder value, you can store the data in your computer memory location using a hash key value. Example, Alice, the phone number is his phone number is 020598555. Okay. Then modulus of 5, the remainder value is 0. Then 0th location, you can store the Alice phone number. The next one is a John. Then John number is 020123456. Okay. Then the remainder value is 4. The based on the key value 4, you can store the data in the particular John. Store the data in the 4th memory location. Sure, the remainder value is 3. Then based on the 3, you can store the data in your particular memory locations. It's a hash key generated in this methodology using a key is a hash key value, hash function h of k equal to length of key, modulus of its 5 is nothing but array size of the table. The next example to hashing keys are authorized elements you want to insert in your computer memory location. The 89, 64, 35, 100, and 47. I want to insert the 5 elements in my computer memory location. The hash table size m equal to, it's called as m is nothing but it's a memory location. M equal to 10. Hash function h of k equal to key k modulus of 10. Then just create a array memory location. It start from the 0 to 9. Then 89 modulus of 10 remainder value is 9. Then 64 modulus of 10 remainder value is 4. 35 modulus of 10 remainder value is 5. Okay. Then based on the remainder value, you can generate the hash key positions. It's the array index positions. Then 100 remainder value is 0. Then 47 remainder value is 7. Okay. Then 89, the key value is called as the array index positions. The array index position 9. In the ninth memory location, you can insert the 89. Then fourth memory location, you can insert the data 64. Then fifth memory location, you can insert the data 35. Then 100, the array index position is the hash key value is 0. 0th location, you can insert the data. Insert the data 100. Then 47, remainder 7, 7th memory location, you can insert the next data. Okay. Then what the purpose of hashing techniques? This hashing techniques is used to easy to retrieving the data from your computer memory location based on the hash key value. Easy to retrieve the data. Without the hashing technique, it's very difficult to retrieve the data in your computer memory location. Suppose without the hashing techniques, I want to insert the 89 in this position, then 64 here, then 35 here. Then means it's very difficult to access the particular data information. Very difficult. So we can use hashing techniques used to store the data in your computer memory location based on the array index. Why hashing? Many applications deal with lots of data. A simple previous example diagram, just I have only 5 data with explanations. But if you have a huge data you want to store in your computer memory location, without the hashing techniques, it's very difficult to access the information in your computer memory location. Is very difficult. So we can use the hashing technique used to access the information within a time period, or within quickly can access the information. Okay. Implement the data structure like arrays and lists, binary search tree, hash tables, implementation of hashing techniques. Okay. It's a constant, it's a solution. Hash table with hashing improve the searching with the constant time. Okay. Constant time means suppose without the hashing technique, it's very difficult to retrieve the data. It's take a huge time to retrieve the data in your table. Okay. Suppose you are using hashing technique, it's a constant time. The particular time period you can retrieve the data in your computer memory location. Okay. Hashing reverse. Okay, what the hashing techniques mean? Keys, elements to be stored based on the key. Hash function maps key to the hash value, and hash value has generated index in the range from the 0 to m minus 1. Okay, suppose I want to insert the 5 data, means the index in range from 0 to m equal to m minus 1, 5 minus 1, 4 memory location. So 5 memory locations start from array index of 0 to 4. Okay, then hash table data structure to store the element array size of m. Okay, based on the key value, you can store the data in your hash position, particular array index position. And hashing functions, mapping of key to indicate of hash table is called hash function. Keys mapping hash key in range from 0 to table size minus 1. Table size m equal to memory locations minus 1. So just assume I have a 5 data. I want to insert the 5 data in my computer memory location. The array index start from 0 to 4, 5 locations. Then based on the array location 0 to 4, you can create a hash key value and store the data in your computer memory locations. Comprise of 2 maps. One is a hash code map and comparison map. Key hash code map into the comparison map. Then index has index range start from 0 to m minus 1 store the data. Okay. Good hash functions. Okay, quick to compute, quick to retrieve the data. Map equal key equal indicates in this. Okay, key without hash function is very difficult to access the data, so you can use the hash key used to retrieve the data. Minimize the probability of collision. Just sometimes more than one element using a same hash key value is called as a hash collision. This hash collision means is nothing but same hash key access the same hash means same array index access the more than one element at the time is called as a hash collision. How to solve the hash collision techniques? Hash collision has solved to solve resolution of 2 techniques. One is a separate chaining and another one technique is open addressing. There are 2 both ways of collision resolution technique. One is a separate chaining and open addressing. Separate chaining is nothing but an array of linked list implementation. This concept of linked list implementation concept used for the separate chaining. Create a hash key and based on hash key you can store the data. Then open addressing, array based implementation. Here in this techniques you have 3 important techniques. One is a linear propping, quadratic propping, and another is a double hashing. Collision resolution techniques, separate chaining is called as open hashing. Then open addressing, closed hashing. In this closed hashing, we have two important techniques. One is linear propping, quadratic propping, and another double hashing. Separate chaining. When a collision occurs, elements with the same hash key will be chained together. Collision is nothing but elements with the same hash key will be chained together. It's sorry, more than one key, more than one memory, same memory location, more than one key access the same memory location is called as a hash collision. In this hash collision solve technique is a separate chaining. In the separate chaining, when a collision is occurred, element with the same hash key will be chained together. The first element have a link with the second element. It's one by one. You can store the data up to end of the data. Chain is simply a linked list of all elements with the same hash key. Okay. Take a simple example. Here hash key percentage of table size is the hash key generation syntax. Okay. I have a data 4220362 sorry, the data are 36, 18, 72, 43, 6, 10, 5, and 15 key. Okay, how to generate the hash key value means 36 is the actual data, modulus of 8. 8 is nothing but array index positions. Start from 0 to 7, array index position 8. 8 positions I have. 8 positions I have. Then 36 modulus of 8, remainder value is 4. Is a hash key value of 36 is 4. Then 18 modulus of 8, remainder value is 2. 72 modulus of 8, remainder value is 0. 43 modulus of 8, remainder is 3. 66 6 modulus of 8, remainder is 6. Then 10 modulus of 8, remainder is 2. 5 modulus of 8, remainder is 5. Then 15 modulus of 8, remainder is 7. Okay. Then first you can store the data for fourth memory location. You can store the data array index position. You can store the data 36. The next one is the 2, then assign as a null position. The next syntax is a null. Okay. And 18 modulus of remainder is 2. 2th memory location you can insert the data 18. Okay. Then next one is the 72. The 72 0th memory location you can insert the next data. 43 modulus of 8. The array index position is 3. Third memory location you can insert the data 43. 6 modulus of 8. 6th memory location you can insert the data 6. 10 modulus of 8. 2 memory location you can insert the data next data. 5 modulus of 8. 5th memory location you can insert the data 8. Okay. 15 modulus of 8. Then 7. 7th memory you can insert the data. Here 2 10 modulus of 8. 2 second memory is already you have another memory 80. So just move to the separate chaining. Okay. Then create a link to the particular memory location and insert the data. If you have another one data, just access the same memory location, just create a chaining link to insert the another one data. So one by one you can insert the data in the same memory location. Suppose I want to access the data, 10 means automatically go to key value. 2 is the key value. Based on key value 2, go to search the locations and access the information for the particular memory locations. Then closed hashing, open addressing. This table size is 10, hash key 10, hash key start from 0 to 9. These are the elements 89, 18, 49, 58, 69. 89 modulus of 10, 9, 18 modulus of 8, remainder value is 8. The 8 is converted to the hash key value. Then 49 modulus of 10, 9. Then just 9th location you can insert the data 89. Next 8th memory location you can insert the data 18. Then 49 modulus of 10, 9 is the memory key value. The 9th location already you have another one data in this position. At the time you can implement the linear propping methodology. You can insert the L plus 1. Okay, this called as the next position. Find the if position is empty means insert the data to this particular positions. Okay, linear propping methodology. Okay. Then next one is a 58 modulus of 10, 8 position already. You have a data 58 modulus of 10, the 8 position you have a data. Then you can implement the quadratic propping method 7 minus of 48 modulus of 7. The 5th position you can insert the next data. Okay. Then has 69 modulus of 10, 9, 7 modulus of 69 modulus of 7. First position you can insert the data. This is using a open addressing with the three important concepts. Okay. Today we are discussing about the linear profiling with the techniques one by one we have discussed with the basic concept of what do you mean hashing and what the purpose of hashing, how to can create a hashing techniques, and how to insert the data, everything we can discuss. And finally, we have discussed the two important concepts. One is a separate chaining, and another one is a closed hashing, open hashing with the linear profiling methodology only we have discussed. The remaining session we will discuss separate quadratic problem, double hashing, and big hashing techniques. Okay. Thank you. Thank you, Joe.